Hey everyone, welcome to another Open Cluster Management Community meeting. Today is July 5th, 2024. On the agenda today, we have first Zhisheng is gonna demonstrate the work that she's been doing with the GPU resource add-on collector. That will really help us with the AI workload scheduling. And then later on, I'll give a little presentation on another method for the ArgoCD pool integration. So first up, Jisheng, whenever you're ready, please feel free to take it away. Thanks.
Okay. Hello everyone. My name is Zheshen, and I'm very happy to be the contributor this year for the Google Summer of Code program, and also contribute my codes to OCM community. Let me share my screen and get started. So basically, uh, can you guys see my screen, or should I?
Yes.
Is the
Yes.
font big enough?
Looks good.
Okay, thanks. So basically, oh sorry, I have I have developed an add-on which helps to collect GPU and TPU resources, um, which is helpful for scheduling the workload, especially artificial intelligence workload. And right now, let me try to demonstrate my work. Okay, so let me go a bit into the background that Open Cluster Management has already supported extensible placement scheduling, which introduce a new resource type, which is called Addon placement score, that can be used to select clusters under certain conditions. So, but with the rapid advance of artificial intelligence and increasing number of developers need to schedule and plan their workloads based on the available resources to maybe to achieve better performance and also like save resources. So introducing this resource usage collect add-on, which collects the resources usage information in the managed clusters. And with it, it calculates the add-on placement score, which the users could select the the clusters they want based on the scores they have for each managed clusters. So in our admin placement score, we focus on resources usage information, for example, like CPU resources information, memory, GPUs, and TPUs. And today I want to give a simple demo about how we can adjust the workload in the multi-clusters with the according to the GPU resources. So we have our preconditions that on our hub clusters, we can see that we have 3 managed clusters. Yeah, like we can see that our managed cluster 1, cluster 2, and cluster 3. And each managed clusters has different GPU resources, which is described as, sorry, excuse me, allocatable GPUs and also the capacity of GPU resources. We can use a command to see the GPU resources. For example, the allocatable and capacity of NVIDIA GPUs. We can see that in cluster 1, it has like allocatable 3, capacity 3, and cluster 2 has in total 8, and in cluster 3 there are 14 GPUs. But this is the information provides the total amount of GPU resources of the managed cluster. But in reality, the managed clusters usually have multiple nodes each node has different GPU resources. Well, this might make the workload scheduling a little bit different. So for example, we log onto the cluster 2 and see, for example, cluster 2 might have like two nodes, that one is the control planner and one worker node that for each two of them that they have different kind of like GPU resources. we could use also this command to see, for example, the cluster 2 has like 4 allocatable resources, GPU resources on the control planner. Also on the worker node, it has same allocatable like 4 GPU resources. Let's log on to the cluster 3 and see the same. Like for example, the cluster 3 have 3 nodes in total, like one worker, and the second worker 2 it has 2 worker nodes and 1 control planner node, and same, each of them has like different GPU resources. Okay, we can see like, for example, the control planner has 3 and the worker have 8 and the worker 2 has like 3. Right now, let's install the resource collect usage add-on. Of course, we have to change back to our managed cluster. Okay, right now we can see that after this command that the add-on is like successfully installed on our clusters. And this add-on is developed with the add-on template, which means that users can see the add-on template as a resource type on the managed cluster. For example, yeah, on the managed cluster, we see the add-on template of this add-on. And also in this add-on template, which we have the benefit of that, we directly describe the manifest files or other resources that we want to install on our managed clusters, which simplify the development, I guess. And after that, we can see on the managed cluster that the resource collect agent part is running, for example. We try to, under the namespace of open cluster management add-on, agent add-on, that's, yeah, for example, the agent part is running on cluster 1. And we can also see cluster 2, which is the same on cluster 3. Okay, and on the hub clusters that the add-on placement score for each managed cluster will be generated. You can see. Oh, okay, so for each clusters, there will be a resource usage score that has been generated. We can see the details about it. For example, for cluster 1, there was like multiple scores. For example, the CPU available score, and the memory available, that GPU available, and TPUs. Of course, like same thing for like cluster 2 and cluster 3. Let's focus on only the scores. So right now we can see that, for example, the cluster 1 has -70, and cluster 2 have -60, and cluster 3 have -20 in their GPU scores. And in this add-on, the score of the GPU, which we want to say as an example today, that the range is defined between -100 and +100. This setup helps to map the like whatever number of GPU resources you have. It could be mapped to the score like evenly. Here, let me see. Okay, so if we wanted to, let me here make an example that here we can see that it's the information about the total GPUs that's on each clusters, but our add-on placement score is not calculated by the total amount of GPU resources of the cluster, but the node in the cluster who has the maximum GPUs. This is very helpful because our workload is usually deployed not on the total clusters, but on a single node. So it's helpful that we know that which node has the maximum GPU resources right now. So the pod can be our workload can be selected and deployed on this node exactly. And the calculation of the GPU score is as follows, that the available GPU equals allocatable GPUs minus used GPUs, and GPU score equals like available GPUs multiple 200 and divide maximum GPUs per cluster. This can be set by the user manually. Here I set it as 20 and minus 100. For example, here I also designed that each node has a independent calculation of the score so that we can choose by node, not by clusters. Right now, let's get into some concrete examples. For example, the user want to create a placement to select one cluster which has the highest GPU score. Yeah, let's see. For example, the placement look like this. Like the user want to select the most one cluster that has the highest GPU score. And we apply the placement. We can see that's successfully created. Okay, right now the user want to deploy a plot which use like 5 GPU resources to a cluster with the highest score to get a better performance or anything. So for example, the job might looks like this. Like we deploy a GPU dummy job which requires like 5 GPU resources. And with our cluster ADM command that we can create this manifest work together with the placement. Yeah, we can see that create my first work in cluster 3. That's because we can see that cluster 3 has like minus 20, the highest GPU score right now. So it has been selected to deploy this pod. And for a sanity check, we can log onto the cluster it's been chosen and see if the pod is actually running. Yeah, let's see. Okay, good. So this GPU pod right now is running in the cluster 3. Cluster 3. And we can see the cluster with the highest GPU score has been selected. And after a while, the user can see the Addon placement score has been changed because the GPU resources had been consumed. And this updating time of the Addon placement score has been set up right now by me by like a 30-second. And the user can set up like with the amount of time that he wants, for example. And right now we can see maybe the Addon placement score. Oh yeah, good. This is a little bit crazy. How about this? Okay, right now we can see that because there was a pod deployed on the cluster 3, so the resources has been consumed, and right now we can see the pod which the GPU score has been changing, like it gets smaller because like 5 GPUs has been consumed here. Yeah, and this score, because this score is calculated by the maximum node that has the maximum GPU resources. So for example, maybe this I will show this later, and let's get to this next case. Like maybe for example, the user want to right now develop another pod which use 4 GPU resources still to the cluster with the highest score. And right now we can see that the highest score is like in the cluster 2. So it's supposed to be deployed into cluster 2. Same, we deploy a GPU pod, sorry, which consume like 4 GPUs. We create a manifest work which combined with the placement. We want placement we created before to select highest GPU score cluster. Okay, right now we can see that my second work is created in the cluster 2. For example, because right now cluster 2 has the most highest GPU score right now. Yeah, and then we can also like do a sanity check and see if there is like really a pod running in cluster 2. Okay, right now it seems like this pod is successfully running in the cluster 2. Here I do this just want to say that for example, the allocatable, this is the total GPUs that on each clusters, no matter, it seems that the cluster 3 always have the most GPU resources. Even right now, a work that takes 5 GPUs is running on it, like 14 minus 5 is like 9 equals to 9, but the workload will still not deployed on cluster 3 because there is no node in cluster 3 that actually can deploy this pod which consume 4 GPUs. So this design will be more reasonable for an actual situation. Yeah, and we can check the Addon placement score again right now. Yeah, we can see that why here the value is not changed because if you still remember that cluster 2 has like 2 nodes that each of them has 4 pods. One pod is taken to consume this 4 node GPUs, but the other pods still the other nodes still have 4 GPUs. So according to the calculation algorithm, the node which has maximum GPU resources will always be chosen as to calculate the score. Yeah, and and we also consider an edge condition if there's no node with sufficient GPU resources, but the manifest will still create on the clusters that has the highest score, which means that okay, the manifest work chose the clusters with the highest score to deploy the workload, but there is actually no node with sufficient GPU resource. It just beat the other clusters, like it just be chosen because it beats other clusters. What will happen? And what will happen is that the pod will be always pending that until there was like another cannot run, it will be pending until there's enough resources again. And yeah, these are all my work so far, and very much thank you for your attention.
This is great, Jisheng. This is really, really good work, and thank you again for your contribution. And thank you, Quinn Hao, for the for helping out with Jisheng whenever she has any questions.
Oh yeah, I really want to commit my thanks to both of my mentors who really helped me a lot in this work. I think it's really a nice experience as a contributor here, and also together working with my mentors. Thank you.
Yes, thank you. I think I'm glad to see you are getting familiar with OCM during this month. And now you can join the OCM community activities actively. I see you can now search for help in the Slack channel and also join this meeting. I hope you can enjoy your trip in the open source communities.
Thank you. I really learned a lot about OCM and also had really great experience.
Yeah, great demo. Thank you for the contribution. I have 2 questions about this. And first is can we select clusters based on the type of the GPU. For example, I have an application, but I want to select a cluster with GPU NVIDIA A10. Can this be
I
supported?
think there is literally a way we can do that, because maybe I could share my screen again. For example, this is my node that, for example, this is what I get from actually get where my computer really has a real GPU environment, which I use this get node which this node has really a GPU resource get inside that. If I use this kubectl get node and I try to get out all the information that from we can see that for example here under the annotation labels, we can actually see the type of the GPUs. For example, if you really mean that the GPU I'm using is like NVIDIA GeForce GTX 16050 Ti, and also the replicas, the other kind of like informations about this GPU, for example, and of course here the GPU type. Is that what you mean?
Yeah.
Yeah, so basically which I attracted that under the annotations and labels of this Yummy documentation of this node, that we can literally see that every information about this GPU, because at that time my computer only have one GPU, so that there's only one product. I believe if the cluster have multiple GPUs, it will show all kinds of the GPU type, I think. Yes.
Okay.
But I think this is because I also installed a NVIDIA K8s plug-in inside this node, so it can expose everything about it. I'm not very sure, but I really remember that I did this step, so the type of the GPU and other kind of information are exposed. Yes. So I
Yes.
think if our add-on want to use this information, maybe it also should connect select or collect informations that's under annotations and labels.
Yes, maybe your agent can give each type of GPU a score. If there is, you can give a 100 score and know it's negative 100. And the user can choose it by setting weight in placement. This is a possible solution.
For example, that people who use this GeForce 1650, that we can give it a score like 20, 30 or so. And then, or it can be selected in the placement. Is that, if I understand it correctly, yeah.
Yeah, it's like that, but I'm not sure what the tab will be like. This annotation seems it's a product. I'm not sure if tab has another label or annotation. Maybe I can talk more details offline.
Okay.
Okay.
For this requirement.
Okay. So I have another question. So for example, I want to deploy an application with 2 replicas, and I want to select a cluster that can deploy 2 replicas on 2 nodes and with a sufficient GPU because the add-on placement score select the the value of the add-on placement score is the maximum value of one node. So for example, I have two clusters, the cluster one, one of the cluster one's node have the sufficient GPU with add-on placement score 100, but I have another cluster, class two, and they have two nodes, and these two nodes have a CPU like can meet my application requirements, but its score is like 80. So in this case, the placement will choose the cluster one, even it only has one node, right? But I expected it will choose the class two because class two has two nodes with GPU I required. I'm not sure if I described it clearly.
So from my understanding that you actually want to deploy two pods on
So
two different nodes.
Class one only have one node and its GPU is higher than cluster two. So the score will be higher than the class two. For example, it's 100, but class two has two nodes but each of the nodes the GPU value is less than the class one. So its score will be 80, for example. So in this case, class one will be selected, right?
Yes, because I think because the placement simply select like from the scores, like which is higher, which will be selected.
Yeah.
So for example, the placement says like, okay, I want to select two nodes, like the weight width equals 2, for example. Oh yeah, maybe the logic from the code could be changed a little bit, adjusted that is select nodes instead of like it selects clusters. I mean like in my code I in the logs and every in the code I also my function also returned the node name. For example, maybe I'm not very sure. I didn't test this case before. That if the users create a placement that selects two nodes, would it be possible like it selects two nodes in different clusters that are not equally the same in the same cluster? For example, as you mentioned, cluster in cluster two.
Oh yeah, it's so right. Also, it's two replicas can run on the same node. Yeah. So okay, got it. That seems makes sense for two replicas running on the same node. So that's good. Yeah, the example I described seems not a reasonable case. Sorry.
It's okay. I mean, it also makes me kind of think of maybe other kind of cases that our add-on should cover most use cases as much as possible, I guess. Yeah. But thank
Okay.
you for the question.
Thank you.
Are there any other question for Jisheng? Well, Jisheng, thank you so much for that demo and all your work, and thank you for staying up late to attend this community meeting.
No problem. But I really feel like I really want to catch some sleep. So yeah, thank everyone's attention for listening to my demo, and I want to say good morning and good night for everyone, and thank you.
Yes,
Yeah, I'm
thank
gonna get
you.
offline.
Yes, please feel free to drop. We're gonna move on to our next topic. Jisheng, you feel free to disconnect and get some rest. Thank you again.
Thank
The
you.
next topic we have, let me share my screen. We only have about 12 minutes, so I'm gonna go a little bit quickly. So, can you all see my screen? Okay, assume it means yes. So we have one of our integration is with ArgoCD, and we introduced earlier, maybe last year or 2 years ago, we introduced the ArgoCD pool model. That's gotten a pretty good feedback from the community and quite a lot of interest from the community on how it enables the pool models for ArgoCD. So give a little bit of background knowledge. So traditionally, Argo CD, it follows a push model where the Argo CD controller retrieves the Git manifest from Git repo and then applies directly, connect to a target cluster and apply it. So I want to present another pull model method where the Argo CD will pull the Git the manifest from the Git repo, and then but instead of connecting to the target cluster, it will rely on the OCM manifest work to wrap those workload, and then the managed cluster, the work agent will pull those workload and apply it on the managed cluster. So how is this different from our traditional our existing pool model? So our existing pool model actually wraps the entire Argo CD application CR. What that means is when the manifest work gets pulled down to the managed clusters, the application CR needs to be reconciled on the managed cluster side. Um, then that means the managed cluster side needs a application control the Argo CD application controller install. So that's another resources, that's another setup that's needed on the managed cluster side, and also means the managed cluster needs to have a connection to the Git repo, because that's where the actual application lies, and it needs to talk to the Git repo, pull C manifest, and apply it locally onto the managed cluster. So with my POC methods, this setup is no longer needed on the managed cluster. So you can see on the managed cluster side in the old traditional pool model, you have the Argo CD install, but on here, there's no such setup. You just need to register your managed cluster, and that's it. The manifest work will contain the applications manifest that are needed to create the application on the managed cluster side, which is introducing the pool model to Argo CD without additional setups. So talk a little bit about the benefits before I head to the demo. So again, the simplicity is the key advantage. The managed cluster no longer need to have setup with the Argo CD controller installed. So it reduces the complexity and having to manage the Argo CD deployment on the managed cluster side. So again, this is the same pool model. The HubSpot model always have a little bit better security because the hub cluster doesn't need to hold on to the credential to directly connect to the managed cluster. And other benefits of this model versus the other pool model is it reduces the polling against the Git repo, where in the old method, each of these managed cluster are talking to the Git repo, and then it might be quite expensive and generate a lot of requests on that repo. You might even hit some limit on the on GitHub or something. So additional another benefit is this current POC doesn't require any images. It's all driven through the CMP, the ArgoCD config management plugin. So, but I mean, if we're gonna expand, if we have community interest to expand on it, we might need to build something. But so far in this POC, it doesn't require any additional building of the images. So I'm about to do a demo. What that demo does is, first it'll pull the looks at the Git repo. When we have the application apply on the hub cluster, it'll pull the Git repo. So it has the guestbook deployment, and then it has the guestbook service, UI service. So when the application reconcile and pull these manifests down to in the ArgoCD controller, the ArgoCD CMP plugin will wrap these manifests into a manifest work. And then when the manifest work is created on the hub cluster, and then the rest of the things is just a fundamental OCM IO. Right? The managed cluster will pull the manifest work and deploy these manifests that way. Okay, so I'm gonna do a quick demo. So I already applied the setup here. So on the left hand side, I have a hub cluster, and then on the right hand side, I have a managed cluster. And on the left hand side, I have the ArgoCD controller installed, and with the ArgoCD config management plugin installed. And then on the right hand side, there's nothing there. It's just a regular a managed cluster with the clusterlet with the OCM clusterlet installed. On the left hand side, also here it's our custom the integration plugin with the ArgoCD config management plugin, where the wrapping of the manifest work takes place. So when I apply the app, so if we let's take a look at the app. So the app is the ArgoCD custom resource. It means, hey, go into this Git, go into this folder, and apply the resources that way. So here, I set the variable here into target cluster 1. So target cluster here is a special environment variable that is being used on the plugin. And if we go back to the plugin here, it uses that environment variable, and that's how it tells the namespace, which is where to generate the manifest work, and that's where the manifest work gets pulled down to the managed cluster. So let's apply the on the hub cluster. And then on the hub cluster, we should be able to see the manifest work gets created. So the manifest work gets created wrapping not the application CR, but instead of the manifest that is supposed to be get deployed locally, instead it's wrapping in the manifest work. So now on the managed cluster side, we can see okay. Now the manifest is applied directly onto the managed cluster. So instead of the hub cluster the ArgoCD controller didn't use any direct credential to the managed cluster in a push model. Instead, it relies on the OCM to pull the application down using the OCM IO fundamental work API. So that's some of the advantages of using doing it this way. It reduces the setup of the traditional pool model, as well as have a little bit better security against the traditional push model as well with the OCM IO integration. Of course, this repo is primarily served as a POC right now, and we really need the community to help expand on this idea and flush out the gaps, such as the application CR status. So if we take a look at the ArgoCD app status right now. So right now, usually when you apply an application, it reflects the the resources that's supposed to be applied, such as in this case supposed to be a deployment and a service, I think. But instead here it thinks that it's a manifest work. So there's some gaps here that needs to be addressed, right? And maybe this is okay, and then we will use manifest work feedback, status feedback to get a better status. But those sort of things needs to be flushed out. And then so mostly this is a POC, and hopefully the community take an interest and expand more on it. Sorry, I went really fast because of the time limit. I might explore it a little bit more if there's more interest in the next community meeting. Are there any quick questions? Well, if not, thank you everyone for joining the community meetings. And let me check any question in the chat. And okay, no question in the chat. Okay, everyone, have a nice day. See you next time. Take care, everyone. Bye.
Thank you.